To predict the electron pair geometry and molecular shape of NF3, draw a Lewis diagram to help visualize how the atoms are bonded and if any lone pairs are present. To begin drawing a Lewis diagram, refer to the periodic table of elements to find the number of valence electrons in each atom. The total number of valence electrons in this molecule is 26. 5 electrons from nitrogen and 7 electrons from each fluorine atom. After drawing the Lewis diagram, count the number of valence electrons in the molecule and compare that value to the calculated number of valence electrons to confirm the correct diagram was drawn. In this molecule, there are 4 electron groups, 3 shared electron groups between nitrogen and fluorine, and 1 lone pair on nitrogen. Therefore, the electron pair geometry is tetrahedral. Since there are only 3 atoms bonded to nitrogen, the molecular shape is pyramidal. The lone pair on nitrogen exerts greater repulsion towards the other electron groups, which causes the bond angle between the fluorine atoms to be 107.5 degrees rather than 109.5 degrees. This is a ball and stick model of NF3. The electron pair geometry is tetrahedral and the molecular shape is pyramidal. The bond angle is 107.5 degrees. Notice that the bonds are located on different planes. Although the lone pair on nitrogen is not shown in this model, it plays an important role because it influences the shape of this molecule. Now, let's figure out which types of bonds are present in NF3. Refer to the periodic table of elements to find the electronegativity value for each atom. Fluorine is more electronegative than nitrogen because of the periodic table trend that electronegativity increases from left to right across the period. To confirm this, the electronegativity value of nitrogen is 3.0 and fluorine is 4.0. Fluorine, being more electronegative, will have a greater attraction for the electrons in the nitrogen to fluorine bonds. This is shown by fluorine having a partial negative and nitrogen having a partial positive. Finding the electronegativity difference between fluorine and nitrogen will assist in determining which types of bonds are present. When referring back to the possible bond types, this molecule has polar covalent bonds. Although there are polar bonds present in this molecule, the polarity cannot be assumed as polar. To predict molecular polarity, begin by drawing dipole moments for each bond. Dipole moments show the direction of the greatest electron density. Start the arrow at the positive end and draw the point of the arrow towards the negative end of the bond. To determine if this molecule has a net dipole, add the vectors together. Begin by drawing the first vector, paying attention to the length and orientation. Then continue by drawing the second vector, starting from the head of the previous vector. Continue to draw vectors until all are used. If the head of the final vector is located at the tail of the first, then no net dipole moment exists and the molecule is considered nonpolar. Since the dipole moments do not cancel, NF3 has a net dipole and is considered to be a polar molecule.